Now we go to number 4. Here we have the diagram shows a sector of a circle with radius r centimeter and center O. The chord AB divides the sector into a triangle AOB and a segment AXB. In the case where the area of the triangle AOB and the segment AXB are equal, find the value of the constant P for each. Okay. So if we see the area of the triangle AOB and the segment AXB are equal. So that's our key point. So we have to find the area of the triangle first. So we have the area of the triangle equals to area of the segment AXB. The area of the triangle, it is what? Half times R times R sine theta. The area of AXB, so we have to find the sector first. So it is half theta R squared minus the triangle, it is half times R sine theta. So I move this, the minus, to the other side. Minus become positive here. So it will become R squared sine theta equals to half theta R squared. So it asks us to find constant P. So the R squared sine theta equals to half. The theta we change into P sine theta. P sine theta R squared. So from here, we can find the P. We move the half to the other side first. So become 2R squared sine theta equals to P R squared sine theta. From here, we can see that the P it is equals to 2. Okay, for the second one, in the case where R equals to 8 and theta equals to 2.4, find the perimeter of the segment AXB. So first, we have to find AB first, the line. This. To find the AB, we can use sine rule. It says that the theta is 2.4. This is 2.4. We must know that the total angle of the triangle, it is 180 degree, or it is pi. So we know this is R, or this is 8. This is 8. So we can find this angle and this angle. So it is pi minus 2.4 per 2. So if we calculate it, we shall get 3.14 minus 2.4 divided by 2. So we got this is around 0.37. This is also 0.37. We can use sine rule to find the AB over sine 2.4 equals to the R. The R, it is 8 over sine 0.37. And from here, we can find the AB, it is equals to So we have to be careful. In our calculator, we have to make this into radian, not degree. So AB equals to 8 times sine 2.4 over sine 0.37. Sine 2.4 sine 0.37. So here I got 15, 15. And then we have to find the arc length of AB. Arc AB. It is theta r. So the theta it is 2.4 times with the 8. So 2.4 times 8, 19.2. So the perimeter it is equals to 15 plus 19.2. So we have 34.2 centimeter. That is for number 4. Now we go to number 5. The first one, prove the identity 1 over cos minus cos theta over 1 plus sine theta equals to tan theta. Usually, I always suggest that the first step that you have to do this one. Choose the most complicated one, the left or the right. If we see, it's very obvious that the left one is more complicated. So we start from the left. So 1 over cos theta minus cos theta over 1 plus sine theta. We know that this is already cos and sine, so we do not have to change anything. We only have to times or make the same of the denominator. So this 1 over cos theta times with 1 plus sine theta over 1 plus sine theta minus cos theta times with cos theta over 1 plus sine theta times cos theta. So here we have 1 plus sine theta minus cos square theta over cos theta times 1 plus sine theta. So from here we know that cos square theta, we can make it into sine square. We have to know that cos square theta equals to 1 minus sine square theta. So this will be 1 plus sine theta minus 1 plus sine square theta over cos theta 1 plus sine theta. 1 minus 1 and we delete. So we have, I move it to here, sine square theta plus sine theta over cos theta 1 plus sine theta. I factorize this one, sine theta, become sine theta plus 1 over cos theta 1 plus sine theta. For this one, we can cancel it. So we have remain sine theta over cos theta. And this one is tan theta. So it's proven. Okay. For the second one, if we meet this kind of question, the second one is always related to the first one. So we shall use the answer of the first question to answer the the next question. So we have 1 over cos theta minus cos theta over 1 plus sin theta plus 2 equals to 0. So this, I can change it. Become tan theta plus 2 equals to 0. So tan theta plus 2, I move it to the other side, equals to minus 2. So if we use the calculator, the theta will be minus 63 degree. So this is minus. Our range or the theta is from 0 until 360 degree only. So we have to make it become positive by plus 360 degree, one circle. So we have 360 minus 63, 297 degree. And then we have to know that the tan theta here it is minus. So for the tan it is minus. Instead that we have the angle in quadrant 4, we have to find also the angle in the quadrant 2. To find the angle in the quadrant 2, I usually use 180 degree minus the value here that I got from the calculator, but I do not use the minus. So I just use the value 63 degree. So 180 minus 63 degree, 117 degree. So the answer for number 5 of the number 5, the second one, it is 297 degree and 117 degree. That's for number 5.